This is section 2-3, simplifying expressions by combining like terms. All right, so let's talk about what is a term. A term is a number and or variable tied together by multiplication or division, but separated by addition or subtraction. So what's that going to look like? Can anybody give me an example of a term? Sabina. Any term. Ryan. 5A. That's one. What else? Xander. 4B. Can anybody make the term look a little different than this? Because both of those really kind of look the same. Sabina.
7 plus 6. I mean 7 plus X.
Not plus. Yes, a set.
8 and then fraction.
How about just 8? Yeah, that's a term. Okay. Can anybody use a exponent in one of your terms? Yeah.
7x to the second power.
Those are all terms. Now let's look at it. Numbers and or variables. So it can be a number by itself. It could be tied together by multiplication. Did you see that? Who said the plus? Tied together by multiplication. This is just a number. That's okay. A number or a variable. A number and a variable. Tied together by multiplication. Is 7 tied with x squared? Are they tied together by multiplication? Yep. Okay, tied together by multiplication or division, but separated by addition and subtraction. So, let's look at some examples. How many terms are here in this line? Ryan? 7. 1, 2, 3, 4, 5, 6. Where did we get 7? Ryan? But remember, it's tied together by multiplication or division. So these are tied together by multiplication, and these are tied together by division. So that's all one term. Do you understand? This is one term. Actually, the term owns a sign. What is the term's sign for 4ABC? Ryan? Negative. Okay, so we actually have 6 terms. Okay, now, now we have something called a coefficient. Does anybody know what a coefficient is? Yes.
It's the variable next to the number.
It's not the variable. Yes.
It's the number.
It's the number in front of the variable. So what is the coefficient in 7x, Sabina?
7.
The 7 is the coefficient. Oh, this coefficient is the number preceding the variable in a variable term. So Sabina says 7 is the coefficient.
Can we write it in our own words?
Yeah. You could say the number that comes before the variable in a variable term. By the way, what is a variable term? We talked about that in the first section. What's the difference between a variable term and a numerical term? Can anybody tell me what a variable term is? Yes.
A variable term is an unknown number to its numeral.
Okay.
To its numeral term. it's the unknown part to it.
Okay, and so what must it have in it to be a variable term? To be a variable term, what must it have in it? Haley.
It must have a variable.
Has to have a variable. So 6x. Right. But I'm just asking what must it have in it?
Yeah, I got confused.
Okay. Okay, so 6 in 6x. Sorry. 6x, that's a variable term. Okay? But 6, what do I call that? Yes. It's a numerical term because there's only numbers in it. If all it has to have is a variable in it to be all of a sudden called a variable term. Okay? All right, what's the coefficient of 3y? Is it Tanya? No. Yeah, it's Tanya? Okay. What is it? What kind of 3? Positive 3 is the coefficient. Good. What's the coefficient of 4ABC? Jasmine.
-4.
-4 is the coefficient. Okay. Next one. What's the coefficient of x over m squared? 6x over m squared. Ryan?
6.
The 6. Good. What kind of 6? Positive 6. Okay, what about the coefficient of k? It's there. We don't write it. In math, we're lazy. We like to be lazy. That's why I got into math, because I'm really lazy. And it's a symbolic language. I don't have to write this out. I can skip this number. Jared. What? Not 0, but if are there 0 k's there? 1. I get lazy with my 1s. So what's there really is the 1. We don't write it. I like that because math lets me save time. And I like to play Candy Crush. So I have more time for Candy Crush. So positive 1 is my coefficient. Thank you, mathematics, for giving me a little bit of extra time for not making me write my 1s. Okay, and 2 doesn't really have a coefficient because it's not a variable term. Right. This has a special name. And we call this the constant. A constant is a term with no variables.
I knew it.
Okay? A constant is a term with no variables.
Can't we just say it's a number without a variable?
It's a numerical term. Yeah. You can say that in your own words. That's good. I like the way you're taking notes in your own words and writing it quicker. So, the constant is the 2. So when I am looking at variable terms, we have like terms and unlike terms. A like term is something like 7x and 3x. They have the same variable. Okay? Why do you think 7x and 3y are unlike terms? Ryan? Different variables are not like terms. 5a and 4 times a. Why are these like terms? Ashley?
They both have the same variable.
That's right. How about 4 and 3a? Why are these unlike terms? Maria?
Because 4, you're not, nothing's next to it, and you're not multiplying anything.
Right, it's not a variable term. There's no a in it. It has to have the same variable. 6m and negative m. Why are these like terms? A set
They have the same variable.
with different coefficients. Everybody say coefficient. What's negative m's coefficient? What? Negative 1. Good. Okay. 3x and x squared. Now this is tricky. Yes.
Well, it's not.
It's not a like term. What do you think?
Because it's not 3 cubed, it's 3 squared, and 3 and 2. Never mind.
Okay, Jazz?
Because the x, like when it's 3x, it doesn't have an exponent like next to it.
It has to have the same variable, the same exponent for it to be a like term. So imagine that x stood for the cost of a small drink, $2. Okay? $2. Is this the same if I replace it? X means $2. Let's just take x and x squared. Let's say I have a drink, and I'm going to be getting a drink for $2. What does x squared mean? So $2 times $2 makes $4. Are these the same value? No, so we can't, it's not the same term. Okay? 4ab and negative 3ba. What? Why are these the same? Jared?
If they both still have A and B, just
Right. If it's straight multiplication, it doesn't matter. Isn't 2 times 3 the same as 3 times 2? That's all they're doing. They're moving them around a little bit. Yeah, commutative. I'm glad you thought about that. What'd you say, like the what? Yep. It flip-flops. Okay, but 2a squared b is different than 3ab. Why is it different? Why are these unlike terms? Ashley?
Because 2 is squared.
A squared is squared, and the other a is not squared. X squared y versus 5yx squared. Now, wait, why are these the same? Micah.
Because they have the same exponent and they are.
Right. And notice, x is squared here. It's not just that they both have a squared term. The x is squared. The x is squared and the x is squared. And the y is to the first power and the y is to the first power. So yes, it's the same term. Okay? Next one. Why are these different? Unlike terms, Maria.
They're different because it's 6m squared n and the other one is 2m n squared.
N is squared in the second one, and m is squared in the first one. All right, so now we're going to do something with these. Now, let's look at these. If I have 7 x's and I add 3 more x's, how many x's do we have altogether? 10 x's. If I have 5 a's and I add 4 times a, how many a's will I have altogether? 9 a's. If I have 6 m's and I take an m away, how many m's will we have? Isahir. Good. If I have 4 ABs and I take 3 BAs away, how many do I have? Ryan. 1 AB. And we generally, in the answer, will put it in alpha order. If I have 1x squared y and I have 5 yx squareds, how many will we have altogether? I have x squared y and 5yx squared. Are they the same term? How many do I have of the x squared y's? No, right here. In this term, how many do I have? Huh? Do I have 0 or do you see 1? So I have 1. If you can see it, you have 1. So how many does that make altogether?
6.
Yeah. I have 6 x squared y. And I put it in alpha order. Okay. All right, so let's keep going. All right. Now, think of your x's. These are like buttons and sticks. This is a short stick. Oops. This is a short stick. And I have 4 of them. And I have 4 here. I have 3 here, sorry. How many altogether do we have?
7.
We have 7 what? We have 7 x's. And what else do I have of these long sticks?
5.
I have plus 5y. Okay? So we really just add the coefficients is what we're doing. We're going to add the coefficients. 3x's plus 4x's makes 7x's. So in number 2, what am I combining together? Add or I combine, I should say. Jeanette,
4A and 3A.
4a's plus or minus?
Minus 3A.
Minus 3a's makes how many a's, Jeanette?
1A.
It's going to give me 1a. And I have positive 6 and negative 2. What does that make?
Positive 4.
That makes positive 4. And I have, oops, what did we say? 4 A's and 1A makes 1A. A plus 4. Forget about this little negative here. Does that make sense? Let's look at my PowerPoint. It might be a little clearer. Okay, why don't you try the next one? Combine what you can, put them in the same pot, and tell me what you end up with. Number 3, give me a thumbs up when you're done. Pause the recording. Okay, which terms can be combined? Let's go with Pedro.
You can combine the x to 2x.
What kind of x is that, by the way?
1.
Okay, I have 1x.
And then the 3y and
The-
the 4y.
Wait. 1x gets combined with what?
With 2x.
And what does that make?
3x.
And what else can get combined, please? Somebody else? Haley?
3y
Positive 3y.
and positive 4y.
And that makes?
Positive 7y.
And then, do I have anything else?
Yes.
What do I have to also write?
Minus.
It doesn't just go away. It's like the third kind of button. Black buttons, no, blue buttons, red buttons, and yellow buttons. The Z stand for yellow buttons. Okay, try the next one. Now, remember, the terms that go together must have the same exponent. Okay? Yep. Number 4, give me a thumb up when you're done. Pause the recording. All right. What goes in the same pile? Let's go with Xander.
5x
5x squared.
and then 4x.
No. Does that have the same exponent?
Oh, no, then 3x
Positive 3x squared.
and then positive x squared.
Perfect. How many does that make altogether?
Actually, I haven't finished it yet.
Okay, well, pay attention. Xander. If I have 5 and 3 more, and how many here? How many do I have?
So wait, with the squared, when they're squared, do you add up the squared number?
Nope, you leave it x squared.
Oh, okay.
How many is it?
So it's 8x squared.
No, you forgot about this one. There's 1 here.
Positive 8x squared.
5 plus 3 plus 1.
Oh, plus 1.
Right, when there's an x squared, we have to count that as 1.
Okay, then, so it's 9x squared.
Perfect. Okay. What else can be combined? Jasmine?
4x
Positive 4x
positive 4x plus positive 6x
makes
positive 10x.
perfect. Questions? Yes. All right, so this is my final answer. I just stopped there. 9x squared plus 10x. I don't combine that. Now, this is not as difficult as it seems. When it says find the perimeter of the figure in the terms of x, what do we do to find a perimeter? Sabina, hold on. You add all the sides. So perimeter, stop, freeze, freeze.
Please excuse the interruption. This is Ms. Delosio. Due to the heat outside, students may eat lunch in Borough Hall. Again, due to the heat outside, students, you may eat lunch in Borough Hall. Thank you very much.
Okay, really quick, we're going to finish this. Shh. So, perimeter, in a triangle, I just do side 1 plus side 2 plus side 3. Write this down. So what is the measure of side 1? What's the measure of side 1? Sabina?
2x
2x. What's the measure of side 2, please? X plus 4. What's the measure of side 3, please?
3x minus 1.
3x minus 1. And then I just simplify it. 2x plus 1x plus 3x makes how much?
5. No,
You guys, wait.
8.
You're forgetting about this one. 6x. And then I also have plus 4 and minus 1 makes plus 3. And that is the value of the perimeter.